Dr. Michael E. Blackwell continues his work toward colonization of other worlds, using the tools available within quantum physics. I've dedicated my life to exploring the boundaries of reality itself, and that dedication is both scientific and personal, a conviction that curiosity, rigor, and courage can expand human destiny. Humans have always been driven by an insatiable desire to push beyond familiar horizons, to map unseen oceans, to climb mountains, to leave our cradle. Today, advances in experimental physics suggest that our tools of inquiry might not only deepen our knowledge, but fundamentally transform how we perceive existence. Large-scale experiments now challenge long-held principles and invite us to reevaluate what we accept as given. Questions that once belonged to philosophers and poets are moving into the laboratory. Can we manipulate space-time? Can ordered matter emerge from a vacuum? What role does observation play in shaping the world? In the Blackwell laboratories, these questions are pursued with instruments, data, and relentless skepticism, because discovery demands both imagination and discipline. My work sits at that intersection, ambitious in scope, meticulous in method, and purposeful in its aim to open new worlds for human settlement. Can space-time be manipulated? Is it possible to create matter from a vacuum? What is the relationship between consciousness and reality? These inquiries are being explored through rigorous scientific investigation in my laboratories. My deep space colonization plans hinge on understanding that it is in the quantum realm where physics first hinted at realities beyond our imagination. Quantum mechanics teaches us striking lessons. Particles can exist in superposition, occupying many states at once until an interaction collapses them. Entangled particles display correlations that defy classical separability, so a change to one instantly informs its partner, regardless of distance. And the vacuum, far from emptiness, seethes with transient fluctuations and virtual particles that pop in and out of existence. Quantum physics is no longer confined to chalkboard equations. In our labs, we test these principles with cold atom traps, superconducting qubits, and entanglement-swapping networks. Quantum computers now harness superposition and entanglement to perform calculations that would overwhelm classical machines. And tabletop experiments reproduce aspects of space-time curvature and particle creation in controlled settings. When entangled particles are separated by kilometers, they appear to correlate faster than light, a phenomenon that probes the limits of locality and challenges classical intuitions rooted in Einstein's era. These findings hint that the fabric of reality may be stitched with non-local threads, connections that run deeper than simple spatial adjacency. If entanglement can be sustained and scaled, it suggests a cosmos woven from hidden links, a tapestry in which distant regions remain subtly, fundamentally connected. I've recognized that advanced interdimensional travel would best facilitate reducing travel time to portions of the universe as yet unknown. To approach that possibility, one of the most intriguing areas of my research involves the very nature of the vacuum. Traditionally viewed as nothingness, quantum theory reveals that the vacuum is alive with fluctuations and bursts of energy that exist for unimaginably brief moments. In the Blackwell program, we study whether those fluctuations can be rectified or channeled, whether structured materials, metamaterials, or engineered boundary conditions can coax usable work from the sea of virtual activity. This is not hand-waving. We design experiments with exotic ceramics, nanostructured surfaces, and cryogenic cavities to amplify tiny effects and measure any net energy exchange. The prize would be immense, an effectively inexhaustible power source to drive habitats and propulsion systems far beyond nuclear density. Skeptics rightly point to thermodynamics and conservation laws. Our approach is to test the limits, refine models, and accept falsification where it occurs. Parallel to energy research, I intend to use the curvature of spacetime to enhance travel speeds. Einstein taught us that time and space are malleable. Gravity and motion reshape clocks and distances. Beyond time dilation, theorists explore closed time-like curves traversable wormhole geometries, and engineered metric perturbations that could shorten effective travel paths without violating locality in the usual sense. Practical experiments investigate high-energy laser arrays, rotating mass distributions, and analog gravity systems in condensed matter as stepping stones toward larger implementations. At the operational level, I will use my innovative direct synaptic response interface to pilot vessels, a neural-linked control system that translates intention into finely tuned commands, reducing latency and allowing a human mind to adaptively manage quantum-informed navigation. The relationship between consciousness and measurement is more than philosophy here. It's a design consideration. The quantum measurement problem suggests observation plays a role in selecting outcomes. Understanding that interface between mind, instrument, and system dynamics may be crucial for reliably operating technologies at these scales. One of the boldest ideas in contemporary physics is the existence of a multiverse, an expansive collection of parallel realities, each governed by its own set of physical laws. And I intend to explore how aspects of that idea might be leveraged for colonization. Different theoretical frameworks propose different multiverses, inflationary pockets that balloon away from one another, quantum branches that realize alternate outcomes, and higher dimensional manifolds suggested by string theory. If even a subset of these ideas holds empirical trace, there may be domains with conditions more favorable to habitation, or at least windows of access that reduce transit costs. My team examines whether state transitions or tunneling processes can be engineered, whether boundary conditions permit stable interfaces, and whether information leaks between branches can be detected. Practical deployment would require technologies that bridge scales, from metamaterial gateways to quantum entanglement-based beacons that establish a reliable handshake across domains. The technical hurdles are enormous, maintaining stability, preventing decoherence, and ensuring safety for crews and ecosystems. There are ethical questions too. What right do we have to enter alternate realities? How do we avoid catastrophic interference? Our experimental program pairs engineers, physicists, ethicists, and explorers to test hypotheses incrementally, simulate outcomes, and develop containment protocols. Each investigation, whether probing invisible dimensions, tapping vacuum energy, or exploring consciousness as an operational variable, is designed not only to expand knowledge, but to ensure any application serves preservation and flourishing. Science stands at a precipice, poised to reshape the very rules governing existence. The stakes are civilization scale. Breakthroughs could mean new power economies, distributed settlements among the stars, and a resilience for humanity that transcends a single planet. Our innate curiosity propels us to seek out the unknown, expanding the frontiers of what we consider real, while careful method protects us from premature leaps. Perhaps the most astonishing revelation of these experiments is that reality is not static. It is a dynamic, evolving mystery that responds to observation, engineering, and discovery. Each experiment acts as a key, unlocking doors to previously unimaginable worlds and offering new architectures for life, governance, and meaning. The universe invites us to venture deeper into hidden realms, secret corridors, and infinite expanses. But with that invitation comes responsibility. To steward findings wisely, to share benefits equitably, and to keep human dignity at the center of expansion. As we step forward, one truth becomes clear. To change our perception of reality involves not escaping it, but discovering what it truly is, and using that understanding to build a future where curiosity and care travel together.